we can graph more complex exponential functions by applying transformations to the base function. So for example, if we want to graph f of x equals -2 to the x plus 1. Now we already know from the previous video what the graph of just 2 to the x looks like. We decided that that contains the points -1, 1/2, 0, 1, and 1, 2. And looks something like this. So now applying transformations, what the negative in front of the 2 tells us to do is to flip the graph over the x-axis. So that's going to take this point from a positive 1/2 to a negative 1/2, this point from a positive 1 to a negative 1, and this point from a positive 2 to a negative 2. So just taking care of that negative gives us something that looks like this. And then the plus 1, the fact that it's in the exponent with the x, that's going to affect our graph horizontally, left or right. And specifically because it's a plus, that's when we're supposed to move to the left. So we need to shift all of our points left 1. So that's going to change the x coordinate of this first point to a -2, the x coordinate of this point to a -1, and the x coordinate of this point to 0. And then connecting these points, here would be the final graph of -2 to the x plus 1. To graph g of x equals 1/3 to the -x plus 2. Here again, we already know what the graph of just 1/3 to the x looks like. That's the one that contains the points -1, 3, 0, 1, and 1, 1/3. So it looks something like this. Now this negative, the fact that it's attached to the x instead of the front of our function, this is when we flip over the y-axis. So that means that this point is going to get flipped over to a positive 1. The point on the y-axis is going to stay on the y-axis. And then the point at positive 1 is going to get flipped to -1. And we're looking at something like this. And then the plus 2, the fact that that is attached to the end of our function, this is where it's going to affect it vertically. So specifically in this case, we want to shift all of our points up 2. So this point is going to get bumped up to 2 1/3. This point gets bumped up to 3. And this point gets bumped up to 5. And then connecting that final set of points, we end up with something like that. So to graph h of x equals 2 times 3 to the x minus 1. This is one where we don't know what the base function looks like yet. So we're going to start by plugging numbers in to just 3 to the x. So when x is -1, 3 to the -1 is 1/3. When x is 0, 3 to the 0 is 1. And when x is 1, 3 to the first is 3. So then when I plot those points, that will give me the graph of just 3 to the x. So now the 2 out in front of the function tells me to multiply the y values. So in this case, we're going to multiply the y's by 2. So this point, which originally had a y value of 1/3, is now going to be at 2 times 1/3, or 2/3. This point, which was originally at y equals 1, is now going to be at y equals 2. And this point, which was originally at y equals 3, is now going to be at 3 times 2, or 6. So this is how the 2 affects our original graph. And then we see the -1, and because it is in the exponent with the x, this is where it's going to affect our graph to the left or to the right. And specifically because it's a -1, this tells us to shift all of our points to the right one. So this point is going to end up on the y-axis. This point ends up at +1, and this point ends up at +2. And I'm just going to connect that final set of points to get the graph of h of x.